So this recording is being made to try and help out those of you that are having trouble setting up the Skynet Autoleveling firmware, Marlin derivative. Um, I'm going to try and do the best I can. Not the best lighting in here or the best recording, but we'll see if we can help prevent any kind of confusion going forward. First, I downloaded the file, the Skynet v1.1 alpha from the files page, and it comes with a couple folders. You have the Arduino 1.63 and you have the Skynet 3D v1.1 alpha. I'm going to start off by opening the Arduino IDE. And starting by clicking open, and you'll see I've already got selected the Skynet 3D version 1.1 alpha. And if you scroll down, there are two INO files or sketches. One's Marlin, which Skynet's based on, and the second is the Skynet firmware. So if I actually click open, it will go ahead and open the Skynet firmware and all of the supporting files as well. They all get open. There's only going to be one that we're going to come back and play with, and that will be this config H, which allows us to make a couple adjustments. So you want to make sure in this that you have the correct selection made. So the 1.6.3 that comes with it automatically has the ANET V1.0 board as a selectable option. So you're going to want to select that as your board. And the port, when you plug in your printer, should enumerate to a serial COM port. I didn't have any issues with it. I didn't have to install any drivers. In fact, my printer didn't come with drivers on the USB stick, so never had issue with it. But I have used this laptop to do multiple Arduino projects in the past. So, and then the programmer I've got selected is the AVR ISP for the Atmel in-circuit programming and Mark II. So all those are selected. You can also see down here in the corner in the tiniest text ever, it also says that down here, ANET version 1.0 on COM3. So I'm going to click the upload button, and what that's going to do is it's going to start the process of compiling the firmware. And this process takes time depending on your processor, hard drive speed, amount of available RAM, I'm sure. It doesn't take a long time. Yours might take longer or a shorter period. This is pretty normal. As you'll see on my unit, I already have the sensor installed. I've been running the Skynet firmware for several months at this point now. I've never had a moment's trouble with it. You can see that the light on mine always stays on, but gets brighter when it's triggered, and the firmware does recognize that as a make and break, so it does function as it should. So right about now it should actually go ahead and finish, and you can see right there it finished. That was impressive timing. The sketch compilation, it actually shows how much of the RAM it used. 87% of the available memory on the Arduino Mega that is on that basically. And then what it's doing now, it's actually uploading, and you can see that right there. It says uploading. I'll actually take this loose so you can see here. When it does reboot, you'll see this part doesn't take a long period of time, but you'll see that when it finishes this right here, it'll reboot. That's a good indication that it's finished. And as opposed to saying ANET version 1.0, it will say Skynet 3D alpha with the programmer's name. Mine did not. I edited more of the program to actually put my name on it as a fun little side thing. Not meaning any disrespect to the individuals involved with the making of the firmware just thought it would be fun that way. So you can actually see that there. And we'll progress on to the next step now, as soon as I get that clamp back in. So what I'm going to do now is exit the Arduino IDE. It tends to hold on to the COM port and makes the rest of this kind of a booger to do. So I'm going to go ahead and open Cura. I personally use Simplify 3D for most of my slicing, but Cura is available to everyone and it's free, and so it makes it a lot easier to do this next step, showing it with this. First thing, you're going to want to have a Cura that connects to your printer or is set up enough that you can get to this screen here. And I'm going to go to File, Preferences, and I'm going to make sure that my printing window type is Pronterface UI. And the only reason I'm doing that is it gives me the ability to control the printer over the serial connection. So I'm going to select a STL file. It does not matter at all what it is. All I'm doing is giving it something to print so that I can select the print with USB button. And when I do, it'll bring up the Pronterface UI. So the first step would be to home the x-axis and the y-axis. It might take a couple of seconds to find your printer. It'll say detecting baud rate. When it's finished, you'll actually have a temperature readout for your extruder and your bed. Then you should be able to control your printer manually with all the options at this point. So the first things first, I'm going to go ahead and move my Z up about 10 millimeters to get it to a safe spot, and I'm going to move the unit out over the table. So I'm going to do this kind of a lazy way so I don't have to push a whole lot of buttons. I'm just going to punch in a G code to send it out to the center of the bed. So that's pretty much dead center of the bed for the nozzle. And what I'm going to do is I'm going to slowly lower the nozzle down until it's just touching the bed. For that to work at this point though, the printer thinks right now we're at Z10 because of where it powered on. So it will not let you go any lower than that. So in order to be able to do that, I have to tell the printer that the Z-axis is actually higher than it is. So I'm going to tell it it's at Z20. And if you wanted to make sure that that actually worked the way you want, you can actually punch in this code right here and it'll tell you that X is at 110, Y is at 110, and Z is at 20 millimeters now. And my extruder is at 0 because I've done nothing with it. So what that allows me to do is I can now bring down my unit more than the 10 that I originally raised it by. Okay, so I've just moved it a whole bunch, and you can see that I'm now at Z11. So I'm 1 millimeter higher than when I started. And you can actually see right here that the paper's still smooth, and I'm going to switch to doing things by 0.1s now. And it's starting to just touch there, and there's a nice solid grab where it drags pretty smooth. So that sets my Z where it is, where the nozzle is just touching. And what I want to do at this point is make sure that my inductive sensor is roughly a millimeter above the bed. And the way I did that was with a simple set of really cheap Harbor Freight calipers. Digital, because I'm too lazy to do the inch to metric conversion every single time, even though my toolbox has a set of dial calipers in it. And I just set it to 1 millimeter and basically set it so that sitting on the bed, that the top of that sensor is, or the bottom of that sensor is roughly 1 millimeter off that bed. And it's not the easiest thing to see, but you can kind of get the idea that that's what I did. The reason being there is that now I don't have to worry about that sensor ever being lower than the nozzle tip. So if the nozzle tip's printing something, the inductive sensor can't hit it. So from that step, I've now tightened these nuts down, and this is 1 millimeter higher than my nozzle tip. Then I'm going to do the all scary white home all button. Now what that's going to do, it's going to home X and then Y, and then it's going to home my Z axis. But first it's going to move the bed, or the extruder, to the middle of the bed, just so it doesn't confuse anyone or freak anyone out. It will not let you home the Z axis unless it's over top of the bed, or thinks it's over top of the bed, because of the fact that it needs that metal to read the inductive sensor. And so it's going to automatically kind of assume that that's going on for the most part. So if I hit white home on Cura, X, Y, it's going to raise up a little bit, move to the center of the bed, and then home again. Yeah. You'll notice it does 2 homing procedures. It moves in kind of quickly. You probably just saw that light flicker, and then it goes to a slow motion, and then it comes to a full on. What you'll notice with the sensor, as I have installed, I have the 4 millimeter variety. The light always tends to stay on, but it gets brighter with read from the metallic, from the induction. I've had 0 problem with the switch since the beginning, so I see no problem with that. It's not how switches tend to react when I wire them up at work in industrial automation, but I typically pay more than $3 for an inductive switch. I tend to spend more like $200 for those at work, so I'm going to chalk it up to the cost difference, the sporadic acting of the LED. Now, homing this way, I now have what should be roughly 4 millimeters between the end of the inductive switch and the plate. Now, if this was a steel plate, I would pretty much guarantee you it's close to 4. It's not going to be with this unit because aluminum is not as inductive as steel is. So what we have here is, now you'll see that the paper slides through freely. Now, this is where we are going to learn to set our offset. So this is what the firmware uses to know when this switch turns on how far the nozzle is from the bed, to set the exact height. So what we're going to do is we're actually going to again punch in a G code. I'm going to do G92 Z10. And the reason I do that is it gives me a nice even number to do the coming math with. So I'm at 10.00 on the Z, and it allows me to go down now. And so I'm going to start moving down and checking my drag right there. So right there is the drag that I would normally want for my printing. It moves easy. I can pull it. I can't really push it too super easy. That's where I like to set my bed height at. So at that point, I now know, if I do my M114 again, that I am looking at a Z of 9.30. Okay, so what that gives us is our offset from one to the other. So we can open up calculator or anything like that. I really feel like this one's probably a simple enough calculation. I don't need to do it, but if we take the original 10 millimeters we had and we subtract our current position, which is 9.30, I hit go, I get an offset of 0.7. What that means is the nozzle is roughly 0.7 millimeters away from the point that the sensor reads. Okay, so what we're going to do is, now that we have that value, we can go ahead and close out of this, and we're going to open back up our Arduino 1.6.3, and we're going to open up, hello, where'd you go? There we go. And we're going to open it back up. And once again, open our Skynet. Now this is where I said that we were going to mess with one other file here. If we go to the configuration.h, we can start scrolling down, and if you go down approximately 60% of the way down the file, somewhere in there, you'll find this section that starts with a commented out auto bed level and grid, and it has a couple of defined features, which are your offsets for your X, Y, and Z. The X and Y offset are the probe center distance from the nozzle. I don't know how accurate they are. They seem to do fine. And then here you'll have 0. Right now, as extracted from the zip file, it thinks that the point where the inductive sensor senses the bed is exactly even with the end of the extruder nozzle. That's not the case. We've figured out through our handy dandy math that we're actually looking at a negative 0.7. Now the reason I say negative is once it comes to the point where this is sensing the bed, we want it to travel an additional 0.7 downward to get the nozzle where it touches the bed. So at that point, that's in the config.h file, and that's changed. I can go back to my sketch, the Skynet version 1.1 alpha, and if I hit upload, it's going to go ahead and do the compile step again, and you'll see down here it's started chugging away again, and it's going to compile this again and upload a second time. I actually had to remove my cooling fan from this video because it was a little bit big and ended up blocking most of the view. So I don't run without one, it just isn't in the video. And you'll probably also notice that I've been lifting this several times and it doesn't seem to be a problem. I actually have decoupled the x-axis from the z to prevent layer shifting. As the z-axis travels up and down, there's just a tiny little bit of side-to-side movement sometimes in the bars, and this way everything stays completely set by the linear slides in the vertical direction, and these stay nice and smooth on that. They do have printed versions on Thingiverse that work well. My printer was not working when I got it going, so I machined those out of Delrin or acetal. So if you look on the screen over here, you'll see that the compile's done. It's uploading once again. And so at this point, it's now going to finish that upload and reboot the processor again. It should be finished right about now. Okay, so now it's rebooted, and what I'm going to do is close back out of this and go back to my Cura so that I can check to make sure everything worked the way I expect it. So again, I'm going to load just the first random STL file I can find, and then I'm going to print with USB so I can bring up Pronterface, and I'm going to allow it to reboot. That is to be expected anytime that you connect up to like Cura or Simplify 3D or even Octoprint. Many times the printer will reboot to establish that communication, but again, you can see when it's done because you'll have the temperature readout and you'll start graphing temp down here. So I'm going to hit home all, and home X, Y, it'll raise up, and it'll come down and it'll do its two-step Z calibration again, which is going to touch I say touch, it doesn't actually touch. And right now it stopped moving, and you can see that there's quite a bit of space, but you could also see that the unit is reading that that spot is at 0.7 Z, which is pretty close to right. So that's got that done now. So the last step then would be to see if the final kind of kit and caboodle works. We're going to put in a G29, which is the auto leveling, so it's going to raise up about 10 millimeter, and then it's going to go around and take its grid pattern. And each spot it probes twice, once fast, once slow, to get that Z pattern. It's going to finish doing that. And that's the bed auto leveling, or tramming, as Tom puts it on his website or video. The last thing probably to discuss would be the start G code. Again, I don't use Cura, but I do use a very, very similar startup code in my Simplify 3D. And this is all the stock that came with the Cura as I downloaded it. The only changes I made, the G28 command, where it was doing X0, Y0, Z0. Again, it cannot home the Z-axis unless it's over top of the bed because of the inductive sensor. It won't read out, floating out in the middle of nowhere, and the firmware knows this to an extent, and so it won't let you home Z until X and Y have been homed first. And once those have been homed, you have to move to a position away from 0 enough that it would think that the sensor is over the bed. If you do the home automatically on the controls of the unit, it puts it out 150, 150, somewhere in there, putting the sensor in the center of the bed, not the nozzle. The next step I did was, after X0 and Y0 are homed out, I actually do a G1 move to X110, Y110, which is nozzle center of the bed, at a speed of 2,500, I think it's millimeters per minute. You could do a lot faster. You could choose a slightly different position. That's just setting the initial Z position for your unit. You will run into heartache if you don't do that before your auto bed leveling. It can set some odd things happening. So we're going to go ahead and move out to this position and then do another G28 or home command on the Z. And then we're going to do our G29, which is our auto tramming or bed leveling, followed by what's the standard, Cura settings when I got it to move the extruder up 15 millimeter, zero out the extrusion length, and then to extrude 15 millimeters. I think originally it's 3. I raised that to 15 for a little bit more consistent results of priming it, and then once again zeroing out the extruder again, and then it takes off. Hopefully this has been helpful. I'm sure people will tell me if it hasn't. But if you have any questions, feel free to drop me a line, and I'll try and answer them as best I can. Thank you.